Okay, finally, here's a problem that's worthy of your talentedness and giftedness. Okay, a 1,350 kilogram elevator moving downward at 5.31 arrests its motion. That just means it stops, right? In 2.10 seconds. Now, by the way, if you stop moving down, doesn't that give you a positive acceleration? So I'll bet the force will be bigger than the force of gravity, right? And then what is the tension in the elevator? How about the tension in the cable? I'm sure that it's very tense in the it's very tense inside the elevator while it's stopping too. You know, elevators are always tense places. So I think the first thing to do here is let's solve the kinematic formula here. Let's see if we indeed do get a positive acceleration, right? So let's just chop off a little space here. Let's go S, displacement, initial velocity, final velocity, acceleration, time, right? The displacement is, we don't care. The initial velocity is negative 5.31 meters per second. Final is 0. Acceleration, we do care, right? And then the time is 2.10. Okay, so let's use V equals U plus AT. That's a U and this is an A. Okay, so the final is 0. The initial is negative 5.31 plus acceleration times 2.10. Okay, and then if you look at this, if we solve this for the acceleration, we'll get 5.31 positive equals A times 2.10. Okay, so clearly the acceleration is going to be positive. 5.31 divided by 2.10. And I get that the acceleration is positive 2.5286. 5286 meters per second squared. Now I'm carrying a couple extra digits and that's okay. I'm actually going to store that in my variable A in my calculator. Okay, so this thing is actually accelerating up. If you stop moving down, you accelerate up. Now, I still need to figure out all the forces acting on it, right? So the force of gravity is mg is 1350 kilograms times 9.81 newtons of force per every kilogram of mass near Earth's surface. That's the gravitational field strength. So 1350 times 9.81. I'm going to store that in W for weight. And that force is 13,243 newtons. So let's that's this force down. Let's draw a little arrow. Okay, that is negative 13,243.5 newtons. And then there's going to be some upward force, right? This will be the tension in the elevator. No, the tension in the cable, right? Okay, so there's our unknown force. It's going to be bigger than this one because we know the acceleration is positive. Okay, now we're all set. We can go F equals ma. Right, so let's delineate our space here. F equals ma. Our forces are unknown force, downward force, right? So 13,243.5. Right, and then that equals 1350, right, times this acceleration, positive 2.5286. Okay? Sorry I ran out of space there, but there it is, right? Okay, so now we're all set. I'm going to go 1350 times this number here, right? I get like 3413.6 or so, right? And then I'm going to add this number to it, right? So plus that number there, right? And I get that the force is equal to 16,657.1, I'll say newtons, right? Now we have, what do we have? We have 3 sig figs here, so I guess we'd have to say, we could say 16.7 kilonewtons, right? That's 16.7 thousand newtons would be our answer, right? There you go. So if there's a Suvat problem, solve that. Then you've got to find the weight. Then you've got to set up your forces. And then you just set up an F equals ma, right? Be careful of your acceleration. Is it positive? Is it negative? Be careful. Gravity is always going to be negative, right? The forces, you know, I don't know, the unknown force could be up or down, right? I hope that helps.